is suppose from the second to the fourth hour of your road trip, you travel with cruise control set to exactly 70 miles per hour for that 2-hour stretch. How far would you have traveled in those 2 hours then? I know we can easily compute this, but I'm looking for a visual model, which could kind of help us along. So the first thing we're going to do, I guess I'll let you write it first. Might be the nice thing.
How is this calculated?
Well, this is the step into calculating area under the curve, which is all calculus is technically centered around.
Seems like multiplication.
Well, it is. As I said, it's a step in the direction. I'm easing you into it. Okay, so having this problem, we know that velocity is distance over time. So if I'm trying to find the distance, I need to take my velocity times the amount of time that I have. My velocity here was the speed I was traveling, which is what?
70 miles per hour.
70 miles per hour. And how many hours did I travel at 74? 2, which means that the distance I traveled was 140 miles. We can all do that. We all understand that, correct? So if I had a visual model of what this looked like, it would be a coordinate plane with 70 degrees marked as my speed. And then if I broke this down into hours, from 2 to 4, I was traveling at a flat speed of 70 miles per hour.
Do you want us to draw that?
Yes, it couldn't hurt. Because I was traveling at a constant speed over those 2 intervals, it was really easy for me to compute the total distance I traveled, correct? But what if I wasn't traveling at a constant speed? So let's assume that, I don't know, from hour 1 to 2, I went a little less than 70. And then from hour 0 to 1, I went over 70. And then after hour 4, I went really, really slow again. Would it still be possible for me to identify the distance I traveled very easily? Or would it just be a bunch of things added together?
A bunch of things.
I would have to calculate each of these individually and add them together to figure out the total distance I traveled. So that's kind of what we're doing today. We're looking at curves that don't have a consistent change at all times, or a consistent amount or consistent speed at all times. And we're finding a way to approximate the total change or the total distance or the total, I don't know, amount of water that has accrued over time using these rectangles, because these rectangles are really easy to find the area of, right? It's just length times width. So Riemann sums are a way of using n number of rectangles to approximate the area under any given curve on a given interval. So there are 3 types of Riemann sums that we're going to be looking at today. The first one is RRAM, which is the right rectangular approximation method. I also like to call this right Riemann sums. Everybody calls it something different though. So RRAM, or the right end approximation, says that when I'm looking at the intervals, I'm using the right endpoint of each subinterval to approximate. This right endpoint of every subinterval then will be the height of each of my rectangles. Since we have a right end approximation, we can also have a left end approximation, which is LRAM. Means the exact same thing. So it's left rectangular approximation method, or a left Riemann sum. And this means instead of using the right endpoint of each subinterval, I'm going to use the left endpoint of each subinterval. And that left endpoint is going to be what determines the height of my rectangle. So we have a right end approximation, we have a left end approximation. We can also have a midpoint approximation, which is MRAM, which is the midpoint rectangular approximation. Or the midpoint Riemann sum. So instead of using the left endpoint or the right endpoint of each subinterval, we're actually using the halfway point or the midpoint of each subinterval. And this will be what determines the height. So we're going to go ahead and jump right into an example because I think honestly that's the easiest way. And once you see a picture of kind of how this works, it'll make a lot more sense. So of course we have a story that goes along with this problem. Why not? Okay, so the story problem says a particle starts at x equals 0 and moves along the x-axis with velocity v of t equal to t squared plus 1 for a positive amount of time. Where's the particle at t equals 5? And then approximate the area under the curve using 5 rectangles of equal width and height determined by the MRAM, which is the midpoint. So once we all have this written, I'm going to start with a picture because a picture here makes it a lot more easy or a lot more clear about what we're doing and what we're using. So on this picture, it's going to be a coordinate plane. I'm only looking at quadrant 1 because I can only have a positive distance and a positive velocity here. Oh, goodness. And I know that my time is going from x equals 0 to x equals 5. So my entire x-axis has to go from 0 to 5.
What do you mean equal width and height?
Okay, so equal width means that each of my intervals is going to have the same width. The height is going to vary, but the width is going to be the same. So I'll show you what it means in a second.
Oh, equal width and height determined by the MRAM.
Yes, and then the height will be determined by MREM. Okay, so my x-axis goes from 0 to 5. I'm going to have my y-axis, which is my velocity, go from 0 to, let's say, 30. So what I'm going to do first is I'm going to plot each of these 1 through 5 and its corresponding velocity, so I know what this curve looks like. So I know if I plug 0 into my velocity function, I'm going to have 0 squared plus 1, which is just 1. So that's going to be my first point. Plug 1 in there, 1 squared is 1 plus 1 is 2. When I plug 2 in, I get 2 squared is 4 plus 1 is 5. When I plug 3 in, I get 10. Doesn't have to be perfect. Clearly, my thing's super duper jank. When I plug 4 in, 4 squared is 16 plus 1 is 17. And then 5 would give me 26. So I know approximately what my curve looks like. I'm going to go ahead and draw the curve too. It doesn't have to be perfect, but it should give me an approximate shape, I guess, of what I'm looking at. So once I have a picture of what this looks like, because we're going to start with pictures, I need to identify which point I'm using on these intervals to identify the height, and then I need to know how wide my intervals are. So I'm going to start with the width of my intervals. In a Riemann sum approximation, it will typically tell you how many intervals it wants, leaving you just to determine how wide each interval is, or each sub-interval is. So it told me that it wanted 5 rectangles of equal width, which means that my n here is going to be 5 because I want 5 sub-intervals. To find the width of each of my sub-intervals, I need to take b minus a over 5, where b is the highest x value I'm looking at, and a is the smallest x value I'm looking at. And then I'm going to divide their difference by the number of intervals that I wanted. So here, b is 5 because it said it wanted to know where the particle was at t equals 5, minus 0 because it's telling me that my particle started at x equals 0, and then divided by the 5 intervals that I wanted, which is just going to give me 5 over 5, which equals what? 1. So each of my intervals is going to have a width of 1, which works perfectly because it's already separated into intervals of 1 width. So 0 to 1 is 1 width, 1 to 2 is 1 width, 2 to 3 is 1, 3 to 4 is 1, and 4 to 5 is 1. Are we all okay with determining the width of each of my intervals? For your homework, it will tell you how many sub-intervals it wants, leaving you to determine the width. We're also assuming for all of today's homework that all of my intervals have the same width. It's not always true, but for starting, we're going to say it is. Okay?
So for width, would it be b minus a?
Over n, yes. Over n. There you go. So now that I know the width of each of my intervals, I need to determine which point on the interval I'm using to determine my height. So am I using the left endpoint, the right endpoint, or the midpoint? Midpoint. So I need to determine what the midpoint is on each of these intervals because that's going to make it a lot easier for me. So what's halfway between 0 and 1? 1/2. So 1/2 is going to be my midpoint. So to draw the rectangle associated with that midpoint, I'm going to go to where 1/2 is. I'm going to follow it up until it touches my graph. And then I'm going to draw a horizontal line that goes across that interval at that 1/2 value on the graph. I know, once we get to the larger, where it's easier to see, you'll see it a little bit better. That 1/2 height only applies to that first interval because that's only the midpoint for my first interval. So then I do it again. What's halfway between 1 and 2?
3/2.
Say it again.
3/2.
1.5, which we write as 3/2. So I'm gonna follow 3/2 up till it touches my graph, and I'm gonna draw a horizontal line as best as I can that goes through where 3/2 touches the graph on the interval from 1 to 2, because I'm only looking at the midpoint from 1 to 2. And then I'm gonna do the same thing for 2 to 3. What's halfway between 2 and 3?
5/2.
2.5, which we read as 5/2. So I do this again, I follow it up till it touches the graph. I draw a horizontal line to the best of my abilities. That spans from 2 to 3. And I keep repeating this until I have all 5 midpoints that I'm looking for. So between 3 and 4 is gonna be 7/2. I follow it up. I draw the horizontal line. I do the same thing between 4 and 5. And that's going to be 9/2. I follow it up to the best of my abilities, and I draw it. So the really cool thing about a midpoint is that when I draw the rectangles, we assume that it's going to be roughly 50-50. On half of it is going to be outside of the graph, and half of it's going to be under the graph. Okay, so if we notice, on each of these, I have a portion sticking out over the graph, which is an over approximation. And then I have an empty portion that's left under the graph, which makes it an under approximation. So this kind of evens it out a little bit. So do we kind of see how the midpoint works from the picture?
Yes.
Okay, so now what we're gonna do is we're gonna find the area of each of these sub-intervals, and we're gonna add them together to get the total area, which is the total distance traveled by this particle from 0 to 5. So when we're doing this, what'd you say? It does. Well, you don't always have to draw the picture. We draw the picture at first, so the visual makes more sense. So you won't always have to draw that. So my area is going to be the width of my interval times the function solved at each of my midpoints. Oh my gosh. So what was the width of each of my intervals on this one? 1, which makes it really, really easy. So I'm going to have area equals 1 times. And then the function I'm going to be plugging these points into is that velocity function. So the v of t equals t squared plus 1. So the first midpoint I had was 1/2. So when I plug it in, I'm going to have 1/2 squared plus 1 plus, and then I'm going to plug in my next midpoint, which was 3/2. And we just keep repeating this until all of my midpoints have been plugged in. And you can definitely use a calculator for this. And then you plug it all into your calculator and you get an answer. Of course, I will work through it, simplifying it the way it is right now. That way you can see how the numbers kind of come together, but you're more than welcome to just plug this into your calculator. got 46.25 when I did it. So make sure if you're using your calculator to plug it in, that you also get that 46.25.
It's freezing.
Is there not an easier way to do it?
Well, there is without the picture, but that's pretty much it. And I just draw the picture because it's a good visual so you can see what I mean by midpoint. You don't have to draw the picture at all. You can definitely do it without that. And I'll show you on the next one how we do it without it. 25. But then SRT starts.
Are we gonna work this? So, what do you think?
Not the whole thing. I don't anticipate.
So we're.
Well, honestly, after writing the notes, we'll probably finish it up tomorrow. But then Friday, we'll see what we're doing.
So the homework's gonna be tomorrow.
The homework we do on Friday.
I mean, we'll do it tomorrow.
Yes, if we have time, yeah. Okay, are we ready for the next example? Does this kind of make sense from the videos that you watched? Did we watch the videos?
Some of us
Watch
did.
them, they're boring.
They were very boring.
We were gonna hook it up and all watch it up there, but
Yeah, that's what Devin said.
yeah, but there was no. So I think Liam watched them and Devin watched them.
My internet's always terrible in here.
You know,
It took half the class just to load.
Oh,
Yeah, that back
that's fun.
But then YouTube was up.
You said
They started.
It might be-
at 50%.
I had to get my vote out. I missed two.
What the-
The ones I learned on the, actually I missed two. Cause like I heard what he was explaining and I knew what he said, but I thought I was hearing it wrong because I don't remember like reading those words in the book.
You should have realized when everybody looked at me, it was like, oh, that those were.
I wasn't look, I'm in the front, I wasn't looking around at anyone.
You will be wrong sounds. Sounds.
So I was trying to think of words in the book and I was like, maybe I'm just dumb and I'm hearing it wrong. But I was just dumb and I got the wrong one. But I got the extra credit, so it's fine.
So we're gonna do this one without a picture. See if you guys like it better. It's your choice. If you always want to draw a picture, that's fine with me. So this one says use the left approximation with the number of intervals equal to 5 to estimate the area of the region enclosed between the graph of f and the x-axis for x between a and b. So then I went ahead and told you that my function is sine of x, and my interval overall is from 0 to pi. So we're clearly going to be plugging this one into our calculator, which means we need our calculator to be in what mode?
Radiant.
Dude, why would I
Radiant,
put this in mode?
Because pi is a radian angle measure.
I don't know, how do I tell it?
You go to mode and you go down to the third line, and whatever it's around, well, whatever it's black around is the mode you're currently in.
I'm in radiant.
Good, you should be in radian. That's good.
What's gradient?
Radiant, you'll not worry about it. Okay. So the first thing we need to do if we're not drawing a picture is we need to determine the width of each of my intervals. Okay, so remember we identified before that my width is equal to b minus a over n. In this particular example, my b is pi because that's the rightmost part of my overall interval, minus 0, which is the leftmost part of my overall interval, divided by the number of subintervals I wanted, which is 5. So when I simplify it out, I get that my width is pi over 5. We're all okay with that.
You wanna finish that out?
Well, that's as far as I can go without doing a decimal approximation. So we'd rather have the fraction.
My brother the other day was telling me how to square root of pi. I said, what are you talking about? He's like, yeah, it's 1 something.
Well, yeah, it's 1 something because it's less than 4, but okay. Anywho, so without the picture, we want to identify what our intervals are. So I know that my first interval has to start at 0 because that's the leftmost point on this axis. If my interval widths are pi over 5, what's the right endpoint of this first interval? Pi over 5. I just added pi over 5 to 0. Which means since my first interval ends at pi over 5, my second interval starts at pi over 5. Then I add pi over 5 to that to get the rightmost point on that subinterval. So what's pi over 5 plus pi over 5? 2 pi over 5.
Wait, so how do we know it's pi over 5?
Because we calculated my width right here. So that's the width. So we take the left endpoint plus pi over 5 gives me the right point.
Okay.
And we take the left and we add, and we just keep doing this. So my next interval goes from 2 pi over 5 to 3 pi over 5 because I just added pi over 5 to that. Then I go from 3 pi over 5 to 4 pi over 5. And then my last interval goes from 4 pi over 5 to 5 pi over 5, which is just pi. So those are the sub-intervals that I'm working with here. Is everyone okay with how we did that? If I was looking for the midpoint then, I would have to add those two together, so my left endpoint and my right endpoint, and then divide by 2, and that would give me my midpoint. But I'm not. What endpoint am I working with here, Devin? Say it again. What endpoint am I working with? Left, because it says use LRAM, which is the left rectangular approximation method. Which means in each of these intervals, I'm only using that leftmost endpoint. So 0, pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5. It's no different than drawing a rectangle that goes from, say, 3 pi over 5 to 4 pi over 5. And my left side of that rectangle is on 3 pi over 5. So that's my left rectangular approximation. So these are the values I'm going to be plugging into that sine of x function and adding together. So when I fill all of this into my area equation, I have area is equal to the width of each of my intervals, so that's pi over 5, times each of these plugged in to sine. I would definitely suggest you use the calculator to plug these in, as it will make your life so much easier. Do it all in his brain.
Let me just do all this.
I think I did.
I calculated exactly how
Probably
to
why,
divide.
I actually know all of them. Always for attitude.
was Jeff mad?
All one.
About failing out. That sucks. What the hell? He was like 10 or something. No, he
I didn't think so.
I don't even think you stopped there.
I don't know. He acted like he was. I've never.
Oh, I
You
can't
said
stand
a crush on me.
Who can't say anything?
Because they all think you like.
Okay, so what decimal did we get?
I thought he liked
Oh, so I get to call on somebody.
it. Wait, what's Adam? I didn't know we were plugging this in.
Yeah.
So we
What
have
is
to put
that?
Each of those numbers.
What's my function?
I don't know. I didn't know what we were doing. Sine.
So each of those is getting plugged in for x and sine. So we're gonna have sine of 0 plus sine of pi over
Alright,
5
sorry, I
plus
wasn't-
sine of 2 pi over 5 plus sine of what?
That's so many parentheses and I never do it right.
What do you think?
It's not.
Should the pi over 5 be in parentheses?
Out front?
Yeah.
Or you can just multiply your answer by pi over 5. But you can put it in parentheses out
How
front.
many parentheses should be up front? 3?
I did 1.
I would just do 1, yeah.
Yeah. Oh.
Are you done?
Yeah.
Means I'm gonna call on you. You can do it on normal calculator too, because they have trig buttons on them.
You know, I'm not doing this
Sure,
parentheses
let my
thing
pizza.
right.
I got it. It's all that.
I don't need to add more.
What'd you get, Liam?
That's wrong.
Mine was like almost 2.
Should be almost 2.
Yeah, it's 1.933, I think.
Why'd you put A?
Because- I didn't write that.
Oh, I got 1.933.
I'm sorry.
So 3, 4. So 3, 3, 8.
Yeah.
No, I don't have time.
Colin, D 933.
So I am gonna call on you.
Wait, so how
I
do we,
can't put any more
with
time
this
here.
format here, how would we find midpoint then?
You would do this plus this divided by 2.
Only that?
I didn't throw it.
That would be your
Yeah.
midpoint, and then that's the number that you would plug in instead
So
of
you don't
this.
have to use the rest of them?
Well, you'll have to do all of these, but you'd have to find the midpoint on each of these intervals, and then that's the number that you would plug in.
What?
Then your answer should be 1.9338.
Can we stop it?
No.
So we would do each
This is
individual
hard.
one.
And yeah,
Oh, no.
Yeah. because you still have to have one for each subinterval, just like we have a left endpoint for each subinterval. Okay, let's do another one.
We do the hardest one we done.
Not do the homework. I feel like there should be one more example.
I need
You
help.
just want one?
No.
Yeah. But we
I'm
don't,
freezing.
but the homework's still not due until Friday.
Are there worthy examples, or are they just extra?
Well, some of them are like table ones,
Oh.
but it kind of works the same way. I guess I could save one of those.
We could do like a right one and do
Ooh.
a table with it.
I want to do this one.
Is it right?
Is it a mid one?
It is a mid one on an interval, so we can try that one.
Would the right be the same thing?
Only we would use pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5, and pi. So you just use the right endpoint.
I'm really
Of
over
each
my
interval.
head over-
Yeah, you're short, anything's up your head.
Seven.
Huh?
I really didn't think I was that short.
It's really not. It's really just plugging it in. But
I also did.
I didn't realize how short I was.
Oh, Jazzy went through while we were just all standing, he was like, "Man, why's your hand so high?" It's 'cause my
I think
hand's like
Devin just like
here
rolling out like,
hey, we can do this one as the last one.
I don't know. What it's
for today.
I thought it was average height. I think I am actually. Well, that's how you're gonna be really showing up to Devin.
Two more
Oh yeah,
things.
that's true. This is right here. I had heels and I'm still like, you're quite short of breath.
I don't understand why there's 2 P's in the word approximate.
Okay, so in this example, it says to use 4 rectangles, to approximate the area under the graph of y equals x squared minus 2x plus 2 from x equals 1 to x equals 3 using the midpoint approximation. So we're going to do this one without a picture again. So what is the first thing that I need to find in order to set up my sub-intervals?
The wood.
The width. Perfect. So I know that n is equal to 4 because it says I'm using 4 rectangles. I know that my a here is 1 and my b here is 3 because it says from x equals 1 to x equals 3. So to find my width, I'm gonna do 3 minus 1 over 4,
Two
Would-
minus one.
which is gonna be 2 over 4, which is 1/2. So each of my sub-intervals will have a width of 1/2. Yes, it is. So now I can start setting up my intervals. So I know my first interval starts at 1 because that's the leftmost point on my entire interval. If the width is 1/2, what's the right endpoint of the sub-interval? 3/2. I just add 1/2 to that left interval, which is 1. So 1 plus 1/2 is 3/2. Then my second interval starts at 3/2. I add 1/2 to that, I get 4/2, which is 2. My third subinterval then goes from 2 to 2.5, which is 5/2. And then my fourth subinterval goes from 5/2 to 3, because 5/2 plus 1/2 is 6/2, which reduces to 3. So we're good there. Everyone okay with the intervals that I set up?
Yeah.
Which endpoint am I using to approximate?
Midpoint.
Okay, so what I need to do now is I need to find the halfway point on each of these intervals. I know, it sounds like so much fun. So what we're gonna do to find that halfway point is we're gonna take left plus right and divide by 2. So on this first one, I have 2 over 2 plus 3 over 2 gives me 5 over 2 times 1/2 is 5 over 4. So my midpoint from 1 to 3/2 is 5/4. I do the same thing on the next one. So I have 3 over 2 plus 4 over 2 is 7 over 2 times 1/2 is 7 over 4.
Wait,
Yes. And then I just keep going.
is it gonna like be like 9?
Yes, it is. Yes, if you figure out the pattern, you can absolutely just go ahead and write it down. I like to write it though in case there are any questions later. Since it is divided by 4 and any decimal you got would terminate, you could also use the decimal version of these, though I hope that you get in the practice of using fractions more because they won't always be nice terminating decimals like these. So now I have my 4 midpoints. So I can set up my area equation. And my area equation is area equals my width, which is 1/2, times each of these midpoints plugged in to this function. So it's gonna take a hot minute for sure. So
Can you write out the parentheses?
like the whole thing plugged in, I wouldn't want to do that for sure. I would just solve each one individually and then go from there, but that's just me.
I'll do it.
Can I stay in Mr. Flores for a little bit for SRT,
Yeah.
finish the lab, and
Yeah.
then I'll come in here with another?
No problem, Matt.
Alright, sweet, thank you.
Devin, did you get it to work out? I will tell you on your homework, I didn't do functions that were quite as much work to plug back in. At least not in general. Oh, did you get it? Look at that.
When I said you because when I saw the quadratic thing, I thought you were gonna have to.
Okay, so this is the example we're gonna stop with, I'm sorry. On your homework, I did make a couple left, a couple right, a couple midpoint ones. So I think there are only 6 on your homework, if I remember correctly.
So is our homework due tomorrow or Friday?
I'm actually gonna say your homework's due tomorrow then, since we finished up examples. I'm not gonna say that we aren't gonna do any more in class tomorrow, and I'm not saying I won't give you time in class tomorrow. I'm just unsure of how much, because I do wanna see if I can show you one more thing that kind of goes with Riemann sums. But overall, how did we feel about Riemann sums?
Hate it.
It's
I'd rather
too
do
long.
whatever
Like,
we
they
did
need
the
to come
last
up
time.
with